Welcome to our Innovative Aviation Ground School series. This class is dedicated to short field takeoffs and landings and is a recording of our session that took place on March 4th, 2021. The objectives for this class is to review the short field takeoff and landings theoretical approaches. So we're going to talk about the theories behind how the maneuvers are actually taking place. And then we're going to walk you through the practical elements of the actual maneuvers themselves, step by step. To begin with, I'd like to ask a quick question of, what is a short field takeoff and landing, right? So a short field takeoff is one that enables you to clear obstacles, right? Gain altitude quickly, but most importantly, it allows you to do those things in the shortest ground roll with the steepest angle of climb. Now, your aircraft might not necessarily have the climb performance as a C-130 with a jet-assisted takeoff, but under the right conditions, you are going to get a good rate of climb, and you will be able to, again, clear those obstacles in a very short ground roll as well. A short field landing is one that enables you to, again, clear an obstacle that's on the approach end, or also to come in a little bit lower so that you could touch down on a preset touchdown point with minimal float and stop in minimal distance. Now, if you look at the airplane flying handbook, a short field landing, they use the language of an accuracy approach to a spot landing. So essentially what you're doing is, again, you're almost selecting a point on the runway at which you will land, again, so that you can ensure that you will have a minimal distance in terms of your rollout, and you'll be able to stop in a very short period of time. So why would we want to do these? And why would you want to use a short field technique, either for a departure or an approach? And the answer is because it's fun and we can, right? But in all seriousness, the reality is, we want to use these approaches whenever we're flying in and out of a short runway, whenever we may be in a situation where we have to clear obstacles or obstructions, right? Or if we're in a situation where a go around is just simply not available, right? We may also use these if we are in an airport environment that has a land and hold short operations taking place. So before we begin our discussion of short field takeoff and landings, we want to come back and we want to begin the conversation with an understanding of our airspeeds. And specifically, we want to look at two airspeeds. Those are Vx and Vy, right? Because for the purposes of these maneuvers, in particular, these two airspeeds become incredibly important in terms of our operations, right? The first one being, right, Vy, right? As we know, Vy gives us the greatest altitude gain in the shortest period of time, right? Vy is what we usually use on a normal takeoff and climb out because, again, it's our best, climb rate of climb. Vx, on the other hand, gives us the best angle of climb, right? That best angle will result in the greatest altitude and the shortest horizontal distance, right? So if we're considering about an obstacle that is the end of a runway that we need to clear, or taking off on a very shorter runway, right? Vx is going to become our best friend. Now, an interesting fun fact, right? Vx and Vy, though they may be separated right now, right? They actually do meet each other, right? And if you do a little bit of research with regards to your specific aircraft, the absolute ceiling is where Vx and Vy finally come together, right? So I have a sample chart here to show kind of at altitude where these numbers begin to align and basically become equal. All right, short field takeoffs. Right? One of the things that you'll notice right away is the short field takeoff is designed and is stated as a maximum performance climb or maximum performance maneuver, right? And the reason that the FAA uses this terminology is because, right, you're in a somewhat of a non-normal operation, right? You're taking off in the shortest amount of ground roll, right? You're also utilizing the best rate of angle of climb. All right. So those things, therefore, are a little bit outside of the normal operations, right? So the objective really is, to take off in the shortest possible distance, clear an obstacle to the end of the runway, right, in terms of the short field takeoff, right? So let's walk through the maneuver itself. So just with everything else that we do in aviation, all right, your short field takeoff begins before you even, take and put the aircraft on the runway environment, right? So it begins by completing the pre-takeoff checklist, right? And most likely, the other element that's going to become critical is your flaps setting, right? So refer back to your manufacturer's POH, for your aircraft to determine what the appropriate flap setting should be for your departure in terms of the short field takeoff, right? For example, in the Piper, right, you're going to put in 2 notches of flaps or 25 degrees, right, to begin your short field takeoff. The other big difference is where you position the aircraft on the runway for departure, right? Normally, right, you may pull out into the runway and be, somewhere over the numbers, perhaps, and aligned up, ready for departure. With a short field takeoff, you want to make sure that you utilize all of the runway available to you. All right. So in order to do that, you might want to hug the end of the runway without hitting the runway edge lights, or perhaps even going off the runway itself. Right. But what you said, you want to use everything that is available to you so that you give yourself the greatest amount of space for your role. Once you are positioned on the runway and you're ready for departure, right, you're going to want to look out again and grab that reference point at the end of the runway, as you would on any other the other departures. You're going to want to stand on your brakes, right, and apply full brakes, and then slowly begin to apply full throttle. Right? Now, a real quick note with regards to that process, right? Standing on the brakes and pulling and adding in full throttle, right? You will read in the FAA publications that research has not necessarily established that this particular approach to a short field takeoff actually results in a shorter takeoff run in a light single engine aircraft. All right. But in terms of the process and procedures that you step through, right, for this approach, right, it is often used, again, like you said, in terms of a training environment. So we're at the end of the runway, we're on our brakes, we've applied full throttle, and we're ready to go. So at this point, we're going to release the brakes, right? And at this point, the ground roll will begin. Right? You want to make sure that you maintain that runway center line using rudder, keeping your wings level with aileron, or have them set as needed if there are any wind corrections that need to be made. And you want to scan your instruments as well, just as you would in a normal takeoff. Right? The goal is to keep the weight on the mains until you reach that liftoff speed. Now, talking about liftoff and that liftoff speed, all right? One of the things that you want to be cognizant of is, the manufacturer's minimum recommended flying speed, right? The point at which your aircraft is going to lift off the ground. All right. So at that point, you still want to keep your hand on the throttle, and you may hear your instructor keep saying right rudder, right rudder, right rudder, right? It's because you want to keep that in there to make sure you're offsetting the torque. All right. So lifting off, right, you're going to rotate as you normally would, except things are going to happen a little bit quicker and a little bit sooner because you have those additional, notches of flaps in there that are going to be creating lift for you. All right. At the time that you do lift off, right, then you're going to want to begin to start to pitch the nose so that you can get on that VX airspeed, right? All the while coordinating with rudder, keeping your wings level as you can with your aileron, but most importantly, keeping your eyes outside of the aircraft as you would with any other takeoff. Now, a few recommendations to think about. Right. Again, obviously the objective is to rotate, close to VX, right? But naturally, airplanes do lift off prior to VX, right? That's just the way they work. One of the challenges that I want to make sure that you do, or one of the things to be aware of, is to make sure that you do not hold the aircraft on the ground, right? Because you don't want to be in a position where you're adding excessive stress to the nose wheel, right? And holding it down because you're going to get into that position where you might end up wheelbarrowing down the runway, right? Let the aircraft lift off the ground, get your nose to the appropriate pitch so that you can accelerate into VX, right? And again, these things will be happening a little bit quicker, right? Because again, like I said, you're generating lift from those extra flaps being in. If you find yourself in a position, like I said, where you're flying below VX, right? Again, make sure you allow the aircraft to continue to accelerate, right? Because if you don't, you may end up in a situation where you're in a shallow climb, or your aircraft may actually settle back down to the runway. So let's talk about that initial climb, right? We rotated, we're now climbing out at VX, and we're getting to the point where we've been able to clear whatever obstacle that is within our pathway on the departure end. So when we have reached the point where we are now clear of the obstacle, right, this is the time that we're going to begin the transition from VX into VY, right, our best rate of climb. Right? So we're clear of the obstacle. We're going to begin to pitch down to bring our aircraft to our best VY speed. And we're also going to begin to retract our flaps, right? As before, we're not going to retract the flaps all at once. We're going to do them incrementally, right? So a notch of flaps, wait a few seconds, next notch of flaps, wait a few seconds. If you should happen to be flying a retractable gear aircraft, a few additional parameters, we want to make sure that we have, in addition to clearing the obstacles and moving to VY, we also want to make sure that we have a positive rate of climb and no usable runway left. Now we're starting to get into the sequence of a normal traffic pattern, right? Pitch, power, and trim. Right? You'll hear that one quite frequently from your instructor as well. All right, so at this point, we might want to trim off some of the extra control pressures and make sure that we're continuing to scan for traffic in and around the airport environment, specifically in the pattern. Right? Lastly, maintaining your extended runway center line. Right? There's a lot going on with a takeoff that might be a little bit different as compared to a normal takeoff. Right? So in addition to worrying about airspeeds and flaps, right, you want to make sure you keep scanning and maintaining the center line as well. So let's talk about some common errors, right, with the short field takeoff. Right? And again, going back to the books and the checklists, right, and what you do before you get into the aircraft, right, it's having an understanding of your performance itself, right? So take a look at the POH, see what your ground rules are, right, in terms of your takeoff and your landing, right? Look at those charts to get an understanding of how your aircraft performs. To assist you with this, right, we also have an upcoming class regarding or related to your POH, right, and performance charts, right? So make sure you register for that class because you'll have the opportunity to kind of dig through some of those. The other errors that take place frequently are, again, utilization of all the runway area, takeoff area that's available to you. Again, even though, for example, with Jimmy Stewart, we have a nice long runway, right? Getting into that habit of positioning yourself closest to the end of the runway and giving you the ability to use all available runway and takeoff area that's available to you, right? Because eventually you're going to fly into airfields that might be a little bit smaller, right? And again, it's just building that muscle memory of, okay, we're going to do a short field takeoff. I'm going to make sure that I'm at the edge of the runway, or giving myself as much available the runway to take off, right? So it goes back to, the setup and the checklists, right? Some other things in the execution elements, just lifting off early, all right? And like I said, holding the airplane on the ground. Right? You want to make sure that you're not doing those things during the ground roll and that initial liftoff. Maintaining airspeeds, right? Make sure you pitch and you really hold, VX and that best angle of climb, right? But at the same time, you also want to be cognizant of the fact that you don't want to be solely fixated inside the cockpit looking at that airspeed indicator, right? That just goes for, most of the maneuvers. Keep your eyes outside with the glances occasionally inside to verify things are okay. And then lastly, perhaps the premature retraction of your flaps and gears, right? Definitely wait until you're clear the obstacles, right? No usable runway, positive rate of climb, right? Before you start, reducing or retracting flaps or bringing your gear up. Now, I did want to show you, again, those charts, like I said, just to give you an example. We'll talk about them in a future class, but here's a nice, beautiful chart out of a Piper aircraft, right, PA-28. As you can see, it looks a little bit more of a graph form versus out of a Cessna POH, where you have a little bit more of a table format. So short field landing, right? Just like our short field takeoff, right? The objective is to either fly over an obstacle at the approach end of the runway and touch down and stop in the shortest possible distance. Or you could also be approaching a runway that may not have an obstacle, but it's still a shorter runway environment where, again, you might come in a little bit lower, a little slower, right? So you can also stop in the shortest possible distance and minimal speed as well, right? If you haven't done so, you can definitely go out to YouTube. All right, if you do, short field landings, probably short field landings gone wrong. All right, this airport shows up all the time down in the Caribbean. There are lots of videos of approaches to this airport, successful and unsuccessful as well. But it begins with, of course, the approach, right? And in terms of the traffic pattern for a short field landing, you are going to actually fly a pretty normal traffic pattern, all right? Because nothing really begins to change until you start to get on to final approach, right? Then we're going to be pitching for a particular airspeed, which we'll talk about here shortly. Again, in terms of preferences, right? If you read the FAA publications, or your instructor may say as well, right? Some folks like to fly a little bit of a wider pattern just to allow the airplane to be configured and trimmed with a little bit of extra time. All right. So again, that may come back to you or your instructor's individual preferences. Perfectly fine. All right. But the idea is, again, making sure everything is set so that when you do turn final, you're aligned with the runway, your flaps are set, your gears down, and you're ready to begin that short field landing approach. So let's move ahead a little bit to kind of where we've referenced, our second phase of this approach, right? And I want to talk a little bit about airspeed, right? Because airspeed becomes really important in terms of the short field landing approach, right? So what we're looking for is an airspeed of VSO. All right, so it's the stalling speed of the aircraft, right? And I like to say is a mnemonic, SO, stuff out, right? So it's the stalling speed of your aircraft when you have the flaps out, your gear down, all right? And the particular airspeed that we're looking for here that's recommended for a short field landing is 1.3 times VSO, or whatever the manufactured recommended airspeed is within your POH for this particular operation, right? So that's the airspeed you're aiming for, right? But again, in terms of the actual approach, it still comes down to pitch and power, right? To control the rate of descent and your airspeed. Right? Now, if you're not flying on a perfectly calm day and you have a little bit of a wind factor, same thing applies for a short field landing, right? No more than 1/2 the gust factor will be added. So for example, if you're flying on a day where the winds are 8 knots gusting to 16, right? We'll take half of that gust factor, right? So between 8 and 16 is 8, divided in half, 4 knots, right? So we'll add 4 knots to our 1.3 VSO. All right. So again, that's the same thing as a normal landing, right? But at the end of the day, right, just be very cognizant of, any additional excess airspeed, right, may potentially result in excess floating when we get down and we start talking about the round out flare. All right. What the FAA is really emphasizing in terms of a short field landing is really stability, right? Because you're going to be in an aircraft that is lower speeds, power on, right? They're really looking for you to maintain precise positive control over the aircraft, right? They want to see that it's a really stabilized approach, just like any other landing, right? If you configure the aircraft and you maintain that precise and positive control and everything's stabilized, right, that will enable you to clear the obstacles, right? Have little or no floating during the round out, land on your aiming spot, and then of course stop in the shortest distance possible, right? So this brings up a really good point, right? When we said land on your spot, right? How the heck do we do this and why is it important, right? I want to talk a little bit about the difference between the touchdown point and your aiming point, right? And this becomes incredibly important, for your landings, specifically because there's a distinct difference between the two, right? Your aiming point is really where the descent angle intersects the ground on the runway. Right? But your touchdown point is the point where you actually touch down on the runway, right? So what's happening in between there, right? And what's happening in there is you're flaring, you're rounding out, and the aircraft is still settling on the runway. So if we're talking about a short field landing, right, and really wanting to land on the spot, a particular spot on the runway, so that we can land and slow down and stop in a very short distance, we have to select an aiming point that will allow us to do so. All right. So for a short field landing, most likely, for example, in the slide we're looking at right now, the aiming point, right, is aimed at the numbers on the runway, right, which is okay, right? But for a short field landing, if we really want to maximize, that shrinking down the distance we travel in our flare and get our touchdown point early on a runway, right, we may want to consider moving our aiming point to the point where the grass meets the end of the runway, right? So that if possible, our aiming point is there so that when we do enter the flare, right, we may touch down just beyond the numbers, right, on the actual runway, right? So you will work with your instructor to figure out, where is your aiming point going to be in the short field landing so that you can therefore touch down at whatever your selected touchdown point is going to be, right? And again, working with your instructor, that becomes important for the check ride because, again, you are going to be asked to identify a point on the runway and land within 200 feet or beyond, that point and 200 feet beyond that point in terms of the accuracy element of it, right? We'll talk about our airspeed and flare a little bit because that distance that you travel during your flare, again, is strongly correlated to the airspeed that you use on final approach, right? Because any fluctuations will increase the amount of flare, will increase the amount of distance you're going to travel during that round out. But we'll get back to here in a second. Conversely, I also want to warn you about getting too slow on your approaches, right? And this goes for any approach, right? But specifically in a short field landing, right, you could get into a situation where, an increase in pitch or full power, right, may actually result in additional descent, right, instead of, climbing, right? This gets you into a period of time that we could talk a little bit about it when we get into the performance of your aircraft in an upcoming ground school class. But what you're in is the region of reverse command or the backside of the power curve, right? It's where your angle of attack is so great and you're creating so much drag, right, that even with maximum power, it becomes a little insufficient to overcome, right? And you'll still continue to settle down. So again, just keep an eye on your airspeeds, again, as you are executing your short field landing. But the good news is, again, if everything is set up and configured appropriately, right, ideally, right, you should really only be making those small changes as needed, right, to correct any element of the descent or airspeed, right? So for example, if you're noticing you're a little bit too high, right, you have a little bit of excess clearance, right, just reduce power, lower your pitch a little bit, and that's going to steepen your descent and also increase the rate of descent and kind of bring you back to normal. If you're a little bit too low, right, increase the power, raise your pitch a little bit, right? That's going to shallow the descent and decrease, that rate of descent overall. All right. So we're now at the point where, we're on short final and over the runway, and we're beginning to think about that flare. All right. Again, our short field approach has been fully stabilized, and now we're thinking about, getting into that flare. Right. So that flare and that round out, right, you've already have gotten to the aiming point, and now you're beginning to wanting to get that aircraft on the ground as quickly as possible. Right. So we want to stop that descent, just like on a normal landing, by beginning to pull back the yoke and holding it there. Right. Now your nose will be slightly higher than it would be on a normal approach, right? Because remember, you're flying it at 1.3 VSO, right? So therefore, a little less flare is going to be required. All right, so keep bringing that nose up, making sure that your power is at idle, right? And the idea the aircraft will settle onto the runway, right? Now, if you have no or minimal floating, guess what? Your approach speed was correct and you're right on and things are going to look good. So the touchdown, right? So hopefully if we've set this up correctly, we're now within either on or within 200 feet of our touchdown point that we've selected, right? Just like you would on a normal landing, right? You're going to want to continue to hold that pitch, except we're going to accelerate the next few steps a little bit quicker, right? As opposed to maybe a normal landing, right? So we're going to transfer the weight of the aircraft from the wings to the wheels as quickly as possible, right? Remember, we want to do this because it's going to help us slow down, get us down and stop in that shortest possible distance, right? And to do this, as we said, we want to keep that nose up and keep using aerodynamic braking because it's going to help us decelerate. But we're also very quickly going to retract all of our flaps. All right, so as quickly as you can, get those retracted, because again, that's going to put all of the weights or quickly transition the weight to the mains of the aircraft. We're also going to want to use maximum braking, right? So get on the brakes, right? Now, time on task is obviously going to make this much more smoother and efficient. So don't be surprised again if when you step on the brakes, maybe your nose wobbles a little bit, right? Again, might just be a little bit of timing difference there, but again, both feet on both brakes to the floor to slow down. The ACS SAMRUN certification standards will say, again, we're looking for safety and controllability throughout the maneuver, but also that you're landing on a particular spot within 200 feet of that spot, right? A little bit more narrow for the commercial requirements, right? But the idea is though, all right, you're able to maintain control throughout the maneuver and it's a very stable maneuver itself. So let's talk about some common mistakes that are made during the short field landing. Right? Again, stability, right? Too steep, too shallow, right? Things are just not where you want them to be, right? This could also correlate to too high of or too low of an airspeed, right? Too low of an airspeed, end up with a kind of poor flare. You might end up with a hard landing. Too high of an airspeed, you're going to most likely experience a little bit of floating on your round out. We talked a little bit about directional control, throughout the landing and the maneuver itself. And then most importantly, again, is this idea of recognizing a poor approach, right? And wanting to continue the landing when you maybe should have considered or executed a go around, right? So if things aren't looking right or not working out well, don't be afraid to use that option. So I want to end today's course related to short field operations just with some fun facts as it relates to the runway markings itself, right? As you know, in terms of the landing, you're going, and as well as the takeoff, you're always looking at, well, how long was my ground roll? Or was I within my spot? Or was I within 200 feet of my touchdown point that I wanted to meet, right? So you could actually use the runway environment as a measuring stick to determine, if you met some of the parameters that you have set out for yourself. So on a standard runway, right, the stripes, the runway centerline stripes, right, are 120 feet long. And the gaps between those stripes on a standard runway are 80 feet long, right? So if you're looking at that 200 feet, right, if you from your touchdown point, one centerline stripe and a gap before the next one, there's your 200 feet, right? So again, like you said, you can use the runway environment to help you begin to gauge, are you in or even coming close to the parameters that you set yourself up for in terms of your landing. The runway numbers, again, like you said, on a standard runway, you're looking at those to be 60 feet length. All right, so again, like I said, if you're using it as an aiming point or part of your measuring, right, between the runway center lines and the gaps and the runway numbers, right, you're going to be able to start to pull together some good measurements, which will allow you to kind of judge how well you're executing your short field takeoffs or your short field landings. So thank you for joining us today for short field operations. Right, we do have some more ground schools coming up. As I mentioned during the presentation on March 9th, we'll have one on performance and weight and balance. We'll be looking at aeromedical factors and decision making, And we're even going to jump into the federal aviation regulations, aviation weather, and some more maneuver reviews mixed in with there as well. So thank you for joining us, and we look forward to seeing you in an upcoming class.